to the train. Join in Zoom, and then I will let you out pad up early today. All right, let me just go to chapter 5, and then we're gonna go back to chapter 6. I just want to spend some time on the conditional probability, which is one of the very important chapters. So we completely finished chapter 5. So I just want to make sure that we can still submit the lead work, lead project, right? So lead work and project will be accepted. And just a minute, I will basically going to give you credit for that, and make sure to convert to the PDF file. And so now we're going to completely go to chapter 6, so that the probability concept, and then we're going to start off with the conditional probability. So let's say we have the P of A given B is simply the ratio between P of A and B over P of B. And for the reason that you might be asked to find the probability of P of A and B, so all we have to do is just simply multiply the two probabilities together. Okay, so this one we call a conditional probability. And this one we call it the given probability. Okay, so this is like the joint probability between A and B, right? The joint probability. All right. Now I would just want to give you some examples how we're gonna deal with that. For example, I give you 8 equal to 0.6. Then we also have P of B equal to 0.2, for example. We also have the P of A and B. A join B equal to like 0.7. Okay. So I want to find the P of A or B, right? So very likely that you're going to see a little syntax like the letter U. So this is what we have to find the or. So A or B is simply, so we know the fact that the P of A or B that is equivalent to P of A plus P of B minus P of A and B. So remember that the OR is going to be the sum of 2, and we subtract the joint. So now we just have to plug that in, right? We just have to plug that in. So you're going to get the P of A was 0.6 plus 0.2, and then we subtract the P of A and B.
Hi.
And for that reason, we don't really have the probability of A and B. We can utilize the conditional probability because the question gives the conditional probability of A and B equal to the P of A given by B times the P of B. So we just simply multiply those two. And so based on the questions that we have, this is 0.7 times.
Wait, I had a question.
Yeah.
This was the Zoom one, right?
We can do Zoom or in
Okay.
person. That's up to you.
Done Zoom.
Where'd you send the Zoom link?
Yeah, I didn't see that.
I sent it on the announcements.
Oh,
I checked
really?
the
Mine doesn't
announcement.
show
Mine
anything.
didn't show anything.
Yeah, it said 11/11 was the last one.
Said for me too.
Yeah.
That's the cat over
I
here.
emailed you about.
Yeah, I'm sorry. I think I just sent it out about like 5:12 because I heard of some students just you're late for the train, you're grinning, they can't come to class. I'm
Yeah.
afraid that you guys are going to miss the lecture, so I have to make sure that people,
Yeah.
Oh, now I see it. Darn.
Wait, when was it posted?
5:12.
Oh, that's why I didn't see
Oh,
it.
well, I was already. Yeah.
all right, I'll let you out early today. Tonight
you.
you won't. Just making sure you like keep up to the lecture. I guarantee you that if you come to class every day, you do your homework, you submit all your work, there's no reason to fail. Also, that we also add 3% of your attendance to your final grade.
What?
If you come to class every day without missing any class, or you miss less than like fewer than three, like if you miss no more than 3 classes, it should be good.
What about 4?
What if you have 5?
Fine.
Well, I have 5, but I have a reason. Like I wasn't originally in this class. So I was absent the first 3 classes because I like transitioned in. So
They have to be very persuasive, like.
I'll make a PowerPoint.
Yeah, if that one of the reason that you was transferred to this class,
Yeah,
different section, that's might be acceptable to send an email. Which I can check that for you. It should be good if you have no more than 3 absences. Yes.
When's the 3rd exam? I can't find
The
it.
final exam going to be on December. I would like 16 to 18.
and that-
wait, that's a lot to class though.
18, right?
And that's like our next exam, and that's the last exam.
The last exam, the final exam. We no longer have the other exam except for the final
Okay,
exam.
that's it.
We have 2 projects. If you have a
Which one?
problem with the project, I'm gonna give that one date.
It's
Just
funny
go
you're
to
the
my
only
summer
one doing it.
project. Just do the part with the summer project. It should be good. As long as you submit your project, I give you at least 75 if you submit on time.
I'll actually talk to you after class. I have another question.
But if you don't submit it, you got 0.
I also had a question. I think you went over this, but does the C mean subset? If it looks like it's A to the power of C, does that mean subset?
No.
Okay.
8 to the power, no, it's not. Yeah, it's not a subset. It's a complement. I'll let you know what it is. So let me just finish that question. So we can compute the probability of A and B by just simply multiplying out the conditional probability and a given. That one's is kind of hard. I hope that you don't see this question on the final exam. So I haven't decided yet. Let me just double check that. So I'm gonna take 0.6 plus 0.2 and minus 114. So that's equivalent to 0.66. So that's the final answers. So one more thing that I really want to mention is that the complement 8. So the complement probability denoted by 80, correct? That's what you asked me.
Yeah. Well, it was like A, C, union, B, set B.
Yeah, this is the homework questions. All right, I'll let you know. So we have the probability of 8C equal to a probability 1 minus the probability of 8. So this can be interpreted that, let's say, so if probability of raining tomorrow is 60%, then probably not raining tomorrow is 40%. Okay, we just simply take 1 minus 60%. So you get 1 minus 0.6. So that is 40%. Okay. I can give you another example. So let's say the probability of passing the class is 85%, for example, right? And probably not passing is 50%. So all we have to do is just take 1 minus that. Okay, so this is AC. And this is what we call A.
Oh,
Yeah, if the A was 60%, the AC have to be not A, it have to be 40%. Okay. So I can give you some example for that. Let's say we have a probability of A equal to 40%. The probability of A and B is 50%. And then the probability of B equal to 30%, right? So can we make a chart at 1 to 5? What are we trying to find? Let's say we want to find probability of AC, for example.
union B.
Union of B, right? Let's say intersection would be first. Oh my goodness, let's say intersection would be, union would be whatever you want, right? So the easy way you can do is to make a table, like 2 by 2 table. I think I show you guys how to do that. I'm not sure. So that means that we're gonna have so this is A. It doesn't matter if you want the column as A and the row as B, or you can just have A as a row and B as a column. That's perfectly fine. Is that good? So this one has to be AC. Remember that they are the complement probability. So ascending for this is going to have this one as BC. And this one is total. So the total for both cases, the total probably have to add up to 1.
Not 100. Oh, okay.
Yeah, 1 is just 100%, right? Let's add up to 100% of 1. Whatever you want to call it, whatever you want to say it, can do 100%. It's 100, so this 140, this 115, this 130. You can do that. So the questions gives 0.4. Are we good? And B will be 0.3. So we can figure out the BT by subtracting 1 minus 0.3. So you get 0.7.
So this is
And we can also find the probability of AC by subtracting 1 minus 0.4, you get 0.6. So now we can figure out the P of A and B, which is 0.15. Okay. And then we can solve for the other. Probably we can take 0.3 minus 0.15. You get this. So you get this one equal to 0.15 as well. Is that good? And then we can also subtract 0.4 minus 0.15.
wait, but
The total have to be 40%, right?
where did you, I know that A,
And B was 15%.
well, no, like in the beginning, it's like A union B,
A union B right there.
but why is it that? Sorry.
It had to be that John probably would.
No, I understand. I'm like saying initially when you wrote it, why is A union B 0.15?
A intersects B. Those are given.
So did you have to solve that, or is that just like the given problem?
They're given problem.
Oh,
You don't
Oh.
solve it.
okay.
They give you a certain clue like that. And our job is to find.
Okay.
Yes, our
Okay.
job is to find this. Don't try to, memorize it. Like assume those values must be given, right?
Okay, so you're given,
Yeah, given that. And I want to find these two.
so you have to say what
0.4 minus
union
0.5.
would total to 0.4.
Mhm.
Uh,
The A probability is 40%. The AC was 60%. The B was 0.3. The BC had to be 0.7. And the same thing, we can also figure out the probability of AC and BC by subtracting 0.7 minus 0.25. Or we can also do 0.6 minus 0.15. So we get this 1.45. Are we good?
so that's the answer, is the table.
No, this is a table, yeah.
Okay.
So the chart gonna give you 3 probability, and we should be able to put it on a chart, like 2 by 2 table. And then I can answer the question. Now, what is the P of AC and B? What is the AC and B, guys? So
That's
AC and
union.
B will be AC right here, and B is 0.15, correct?
So that stands for union, right? Or
The
complement,
joints.
okay.
This one means stand for the joints, probably AC and B. I would think the joint between them. The union we have to add
So then
some.
like BC union AC would be 0.45,
No,
why?
BC you join with the BC join with the AC with 0.45.
Okay, just,
The joint is not, the union and joint are 2 different things.
wait. Oh,
This is the joint. This is the joint probability. And the syntax that you have, I know some of the Greek letters, this is what we call the union.
so the union is the overlap, the joint is like the total of the sets.
No, the joint is basically take the common members common sets. The union, we're gonna take all the members without overlapping.
Okay.
Okay. So this is what we call it. This is what we call the union. So the joint probably just simply take the intersection between the B and AC. The B and AC, so we get the answer, which is the joint. That would be 0.15, correct? Just take the joint for that. Is that good?
Yeah.
And now if you want to find a union, that's a completely different story because you need to add up the probability. I want to find the union between AC or B, right? Or, so the keyword or you have to add and subtract. So I'm gonna add up the AC, which is 0.6, and B, and we have to add up these three, correct? AC and B, right? No. Which we have to add up these three boxes.
Oh, because that's me.
That's the union. We have to count all of these three. A, C, or B, correct? A, C, you have to count all of them without overlapping. Okay. So the union, we have to count a lot. The
What?
joint, we just take the intersection.
Okay.
Okay.
What if it were like, what if the elements within the sets were like words, not like actual numbers that you would like add or subtract? Do you know what I mean?
Yeah, so you need to understand which part of the questions that we have to fit into the box. The box that we have right there.
Okay.
Yeah. I know what you mean saying that.
Yeah.
Well, I'm going to give you the questions that the P of A, not a P of A, like the part of something going to happen was
Yeah.
40%, something that and something else was 20%, and something that going to happen will be 20% as well. So you have to fill out charts and all kind of things might require a little more work to set up the table correctly. As a matter of fact, I'm going to have this one is 0.15 plus 0.6. So just add, so we can take this plus 0.15 plus 0.45. So we get this 1.75. Okay. All right. So that's the next part. And then,
Should I take a picture of that?
yeah, absolutely.
I was stuck on this on the homework.
Just make A, AC, it has to be on the same row or the same column. B, BC must be on the same row and the same column
Okay.
because
I get that.
they are the complement probability they can't intersect. The only thing that they can intersect would be A, B, A, C, and B, A and B, C, and A, C, and B, C.
Okay.
Yeah. All right. So now we're going to move up to the last chapter, which is called A theorems. We can also make a chart, or we can also make like the tree diagrams. Okay. So Bayes' theorem can be used to find the posterior is probability. For example, I can give you a lot of examples for that. So let me just give you one example and see what it is. So for example, and then after that, I'm going to give you the form. The form is kind of complicated. Let me give you that one on chapter 6. I know it's got to be like, so which is why I don't want you guys just memorize it. I want you guys to be able to understand it and set it up on the exams. This is what we have for the form. So in other words, I want to find P of B given A if I know P of A given B. It's kind of like go the opposite. I will give you one example for that to elaborate on the process why it's so important, you know. So for example, we have the likelihood, the probability of a person catch a flu is okay. Okay. And now we also have tests, right? And the student people will have tests. All right. And also we have the fact that the false positive is, I don't have space for that. The false positive is 30%, and the false negative is 25%. Okay. All right, so there are a few parts. What is the probability? By the probability that a person who got a positive test. Okay. Are we good? So part B, if given that if that person got a positive test, what is the likelihood
This meeting is being recorded.
that person catch it? Okay, so you're definitely going to see this question on a final exam. So there are two ways of doing it. You can make a chart like that. We can also make a tree diagram to answer this question. So the two approach. Tree diagram or the table. So let's say A, AC, B, B, C. Okay. All right. So let me start off with a question. On the exam, the tree diagram only involving two branches. Okay. The first branch was started with something with the flu and not catching a flu based on the question. So this one, doesn't have any conditional probability. The first one that you're going to start off with must be something that without conditional probability. So that the flu and not having a flu. All right, guys. So the likelihood that it's catch the flu is how much? 20%, correct? So we can figure out 0.2. And the likelihood that person does not catch a flu is 80%. How can I do this? I'm going to take 1 minus 0.2. So I got 0.8. I'm going to let you go after this question. Continue on it next Tuesday. Okay. Now we're gonna take all of these people to the test. You have two case scenario. So they may caught a positive test, they may caught a negative test. Positive means that they have disease, they got a flu. Negative means they doesn't have flu. Same thing for people who do not get a flu. When we took them to take the test, that there were two outcomes, positive and negative. For some reason, the device might not be working properly. So you might have some situation where people caught a flu and that comes out negative. And then
Julia break. Can you fix my attendance from Thursday? I was here.
I don't take attendance today.
Thursday. I was here.
Last Thursday.
Yeah.
What's your name?
Will.
Gotcha.
Thank you so much.
Well,
Enjoy your break.
all right. And the same situation that happens for those who have a positive test, those who doesn't catch the flu also have positive or negative, correct? So now the question says the false positive is 30%. The false positive being that those who took the test and have positive results, but that person doesn't get a flu. So that means that the false positive have to be 30% in this case. This might be put it on the second branch of the trees diagram, correct? Because this person got positive but doesn't have flu. So what we call false positive.
So. Okay.
Test is positive without having flu. Are we good? So we have to put it like on the second branch here. Positive without having the flu. And then the false negative that happens is again that well supposedly that person who got a flu tested positive, but for some reason the device only 75% accuracy. So that basically results with 25% of those who test negative, even though they got the flu. So that 25%. Are we good? Essentially, then we can also figure out the added range. Remember, the total range have to add up to 100%. So we can also figure out the top range will be 1 minus 0.25, we get 0.75.
But you did 1 minus point, oh, okay.
0.25. And the same thing, we're going to take 1 minus 0.3.
Oh, so it's 0.7.
It's 0.7. Okay.
So.
So the question asking us to find the probability that a person got a positive test. So the positive have to be the sum of the trees. This is positive, correct?
Mhm.
We have to count those who got a flu and those who did not get a flu.
So just all the positive.
All the positive of those two branches.
That
Positive.
equal over 100%.
We count, we don't divide, just simply, we don't divide for the first one, we simply count two branches that include positive test. Okay. So this one is the false positive, this one's full positive. Correct? So meaning that the person who did not get a flu but still test positive, it's called false positive. So in other words, you can find a probability of positive by multiplying 0.2, because this one a conditional probability times 0.75. Plus, we're going to take 0.8 times 0.3. So we're gonna get this one equal to, we can do it on the calculator. That we got 0.15 plus 0.24, 0.39. So that's the likelihood a person who tests positive, given both those who got a flu and without getting a flu.
So positives and false positives.
I mean, they both positive, but those who do not have a flu,
Okay.
which we call false positive, and those who got a flu, which is also positive. Now we're gonna go for part B. I want to find the likelihood that a person catch a flu, given that the person tests positive. Right? So now we just look at the ratio. What is the ratio? Which branch that indicates the person who got a flu, given that a person tests positive, the first branch, correct? So that's going to take into account the first ratio of 0.2 times 0.75 over the sum of these two branches, which is 0.2 times 0.75 plus 0.8 times 0.83. So that's going to give us the final answers. Remember that we always have to take one of these branches divided by total of the sum of those two branches for the final answers. So that's going to give us 0.2 times 0.75 over the sum of these two. So we got the answer is 38.4%. So what does that even mean to us? Why do we have to compute the posterior probability? Well, first of all, we know the fact that the person who tests positive, given that a person got a flu, was 75%. But now, I do the opposite. What is the likelihood the person who got a flu, given that a person who tests positive is only 38.4%, right? So this tells us the test is not so effective in terms of coming out the results with both situations. Like the person who got a flu test positive was 75%, but the person who do not have a flu and still test positive, which are 30%, that's pretty high. So based on that both situation, that we can tell that the effectiveness of the test is very, very low, like 30%. So we shouldn't use that test for the next outcome. Okay, so this is what it means. By doing the posterior probability, you're going to help you how effectiveness a certain thing that going to take place. Are we good? Any question? Any question from the Zoom people? All right. If there are no questions, then I will let you go. Okay. All right, guys. So have a wonderful break, and I'll see you guys next Tuesday.
I have a question. Happy Thanksgiving.
Yeah, question.
So since I came today, but I have an absence from another day, can you use today and take away one of my absences so then I fall into 3 and I get extra credit because I need it because I'm not gonna math?
Yeah, I'll consider that. I'll do that. Just an email which day it was absent, and then we're gonna do it next Tuesday. Just don't forget to tell me, please.
So I won't.
All right.
I will not do that. Thank you.
Okay. All right, guys. So I hope that this is going to be really helpful because even if it's like A given B, now we want to find B given A, but that's going to tell you how effective that is of the information B on A instead of A on B. So
Oh, I know.
Yeah, that is one of the things.
Where is that?
All right, guys, so have a wonderful break. I will see you.
See you next Monday. Thank you.
Get me. All right, guys.
I don't know if I want to drink as well. But it's like coffee. I don't really want coffee right now unless it's like Wawa.
I don't want to buy.
I know I don't. I'm like hoping.
All right, happy Thanksgiving.